Today we're very, very pleased to have with us Professor Adam Brown. Professor Brown is Associate Professor in the Department of Art History, and Design. He is an internationally recognized intermediate artist, scholar, and educator whose work incorporates art and science hybrids, including living and biological systems that examine how human entanglement with other species shape our histories, stories, and myths. Professor Brown created a new area of study called electronic art and intermedia, and he's head of that area in the Department of Art History, and Design. In addition to an active teaching and research practice, Professor Brown directs the Bridge Artist in Residency, a program designed to immerse national and international artists within the creative space of scientific inquiry and research at MSU, connecting the arts, sciences, and humanities. I also mentioned he's a member of the advisory board for the MSU Center for Interdisciplinarity. So we're very grateful to have Professor Brown on campus and to have him connected with the interdisciplinary community and doing all of this wonderful interdisciplinary work himself. Today he's with us to deliver a presentation entitled Bioremediating Greenness, Rethinking Human Exceptionalism.
All right, thank you, Michael. It's nice to be able to speak in front of my colleagues and friends. Normally I'm speaking in front of people I don't know when I travel. So, and to also keep in mind, this is for you guys. I'm giving you the added pleasure of providing you with a very rough draft. This is new work, so I would very much value any feedback that you'd want to give me or questions that you could ask to help me with my work. So to start with, I'm actually going to talk about three things. One, real briefly, I'm going to just talk about kind of where I'm coming from, my perspective. The second part, I'm going to talk about a work that's actually currently in the Broad. And then finally, the third part is going to be probably the bulk of the lecture, which is going to be the new work of bioremediating greenness. So intermedia is a philosophy that provides a framework for breaking down and combining different models of thought and bringing together disparate disciplines, leading to the establishment of new forms of research and creative activity. This is an intermedia chart made in 1965 by Dick Higgins. An intermedial approach is designed to emphasize the dialectic between the media. It's concerned where the circles overlap instead of so much the established circles themselves. It's concerned essentially with the liminal. So as being interested in this liminal space, the platypus seems to make a good embodiment of a mascot for intermedia. It's an animal that's in between, that has essentially all of the different organisms on the planet combined into one mashup organism. It's an egg-laying, venomous, duck-billed, beaver-tailed, otter-footed mammal who baffled European naturalists when it was first encountered. And for me, biology is a very good way to think about how we work together as groups. And then in 2008, scientists actually sequenced the platypus, and it turns out that what it looks like on the outside actually was very true of what it was on the inside. It was a composite of all of the different organisms on our Earth. So this is the new, sort of the updated 2018 version of this chart, which basically shows how art makes a larger circle that it can incorporate and capture all of the various different types of disciplinarity that are on campus here at MSU. So art does not necessarily equal science, but sometimes more than one objective can be accomplished at the same time. And that's one of the things that I try to do with the people that I work with here on campus. So how do artists and scientists work together in meaningful ways, and where one is not compromised and both have meaningful and non-marginalized interactions? So the way that I think about interdisciplinary in itself with interacting with scientists is that it's kind of like internet dating, right? So when you go on the internet and you're trying to find a partner, you're looking for things where there's common overlap. And that's the same thing that you would do when you're looking to find some kind of collaborator. There needs to be a common interest. We humans find ourselves in a current predicament. and an ecology deeply affected by human activity. It was born out of the belief that humans exist outside of the natural order, or human exceptionalism. For more than a decade, I've been creating work that attempts to destabilize our anthropocentric, or human-centered view of the world by examining historical relationships between human and non-human species in living systems. For centuries, the great monotheistic, and this is the first piece that I'm going to talk about, which is the one that's currently in the Broad Museum. You can go see it for yourself. For centuries, the great monotheistic religions, such as Catholicism, proliferated stories about autonomous human mastery over all other organisms. Touting that man was made in God's image has blinded us to the fact that we are indeed interconnected to nature and that our histories have been influenced by non-human species. Irreverent is an artwork that examines the impact of invisible microbial agents on the course of human history and belief systems. Specifically, this artwork creates a miracle employing Serratia marcescens, a microorganism that grows on bread and creates a viscous fluid that has an uncanny resemblance to blood. Physically, the installation consists of a bioincubator inspired by medieval Roman Catholic monstrances. A Eucharist host is placed in the oculus, or the center, then microdroplets of media containing the strain of Serratia marcescens are delivered to the bioincubator. Over the course of 2 days, the inoculated host will incubate the microorganism, causing the wafer to bleed, thus producing a blood miracle on demand, similar to those in churches centuries ago. The installation intends to destabilize human exceptionalism by questioning how human entanglement with other species shapes our histories, stories, and myths, and redefines our ontological status. So I like the way Spinoza talks about miracles, and that as nothing happens in nature which does not follow from her laws, and as her laws embrace everything conceived by the divine intellect, and lastly, as nature preserves a fixed and immutable order, it most clearly follows that miracles are only intelligible as in relation to human opinions and merely mean events of which the natural cause cannot be explained by a reference to any ordinary occurrence, either by us or at any rate by the writer and narrator of the miracle. And this was a 17th century philosopher, so this is fairly old but fairly apropos. So this is an image taken in November 24th, 2009 in Korea, which was an actual miracle that was sanctified by the Catholic Church and shows evidence that we still believe in this currency of miracles. Over 2,000 years ago, the ancient Phoenician, now Lebanon city of Tyre, was a thriving commercial center featuring a prominent Mediterranean harbor. The island city, located 1/2 mile from the Phoenician shore, was heavily fortified, surrounded by massive defensive walls, making it a key naval base. In 322 BC, when Alexander the Great, on his famous march, was denied entry into Tyre, he decided to besiege the city. The Macedonians under Alexander worked for 7 months to build a causeway to the island from the mainland so that their catapults could breach the walls. The weary Macedonians, laboring to finish the causeway under a constant rain of arrows and stone balls, were going to give up if it were not for an omen. When the Macedonian soldiers broke bread, drops of blood trickled out and dripped onto the floor. The presence of blood was read as an omen prophesizing the destruction of Tyre. Quintus Curtius Rufus, don't you wish you had that name? The Roman historian in History of Alexander the Great, written in the 1st century AD, elaborates as follows. This is actually a picture of Tyre in the turn of the 20th century. Among the Macedonians, when some of the soldiers happened to break bread, they noticed drops of blood trickled out. And when the king was alarmed, Aristander, the most skilled of the seers, declared that if the blood had flowed from without, it would be an unfavorable omen to the Macedonians. But on the contrary, since it had flowed from an inner part, it foretold destruction for the city, which they had determined to besiege. The Macedonians completed the causeway, captured Phoenician ships, stormed Tyre, killed 8,000 Tyrians, and sold another 30,000 into slavery, leaving Tyre in ruins. This is just one example of many reported throughout antiquity, citing the miraculous appearance of blood on food. Many microbiologists agree that it is likely that the appearance of blood, at least in part, was due to a microorganism invisible to the eye. The bacterium produces a red, blood-like pigment called mucilaginous prodigiosin. Ubiquitous in our environment, this microorganism exists in the soil and is responsible for the pink-colored material that you might find in your shower. And that's what that's 2013. Countless historical accounts of blood flowing from Eucharist bread were recorded during the Middle Ages. Starchy host bread within the damp walls of the medieval churches must have made an excellent incubator. In 1264, at Civitavecchia, pardon my Italian pronunciation, on the coast north of Rome, there occurred a miracle in Bolsena. In the Church of the Holy Christina, the priest was blessing the elements of the Holy Communion, at the same time doubting the truth of transubstantiation, or the turning of bread and wine into the body and blood of Jesus. Drops of blood fell onto his linen robe. He attempted to hide the spots by folding his robe. This caused more bloody figures of the host to appear. The robe was reported to have been exhibited as a relic in Civitavecchia until recent times. And in fact, Raphael commemorated this event in his fresco painted in the Vatican titled The Mass of Bolsena in 1508. An alleged desecration of hosts by Jews in Sternberg, Germany in 1492. As a result, 26 Jews were burned, and this is a German woodcut made to commemorate the event. So, also in terms of showing a miracle, it was also a way of proving the fact that this transubstantiation of Christ was real and that currency was real, and that if Jews are able to stab the bread and cause this bleeding thing to happen, that's more substantiation to the fact that it's true, right? So it's a kind of a weird negative argument, but it was highly effective. In more recent history, during the 1950s, Serratia marcescens was used as a biomarker. In its most controversial and ironic use, it involved aerosolization experiments by the U.S. Army to study the vulnerability of U.S. populations to a bioweapons attack by the Russians. Navy ships sprayed thousands of gallons of Serratia marcescens all over the San Francisco Bay Area. And unfortunately, the strain of S. marcescens they were using was a BSL-2 organism, meaning it could cause infections and could hurt you. I'm not working with that one. And cause non-sequelae infections in hospitals, right? So if you have like a catheter and this gets onto the catheter, your body has a hard time fighting it off with antibiotics. So that was kind of the research that was done in terms of just like book and library types of research in the more traditional sense. And then I decided to take a trip to Gottweib Abbey in Krems, Austria, which is the oldest library in Europe, and met with Father Gregor to find out more about blood miracles firsthand. And that led me to Polkau, or the Church of Holy Blood, in Polkau, Austria, and this is an altarpiece from 1338. And it's a commemoration, and I'll explain the commemoration. The first is an event, a terrible but all too common type of 14th century event, the massacre of Polkau's Jewish community on April 23, 1338. According to several Austrian and Bohemian chroniclers, on that day, a crowd had gathered in the town center in response to rumors that a desecrated host had been found on the doorstep of a local Jew. Passions, we are to infer, flared into violence, and most possibly all of the town's Jews, numbering about 150 persons, were seized, brutalized, and massacred, and their possessions plundered. This altar commemorated the event. I'll give you a close-up here once this video stops, but you can see on the left and right sides of the closed doors that there's actually an image of a Jew stabbing the bread and having it bleed, and on the right, trying to hide the evidence. I'll give you a closer look. Reports indicate that victims were burned alive and reduced to dust. Some of the victims, unable to flee from their persecutors, committed ritual suicide. a form of martyrdom, Hebrew sources called Kiddush Hashem, sanctification of the divine name, in order to avoid forced baptism. And then now they keep those doors open to the public. Of course, they hide the doors, but fortunately I was able to talk the priest into closing them for me to document it. That was another conversation. So from there we went to the sort of on-site research, and then now into the lab. And so this is an image of Serratia marcescens on the right, and then the biofilm, the exopolysaccharide matrix on the left, which produces the blood-like material called mucilaginous prodigiosin. And we're doing some tests in the lab. This is with Drew, an assistant who's no longer with me. He's in Cambridge. And we tried to see if we could reproduce the results of blood bleeding in the center of bread, much like what was described for Alexander the Great. And that seemed to work out okay. These are our images of I call them the extreme lab cam, and you'll see a couple more of those in a minute. Another view. That's the extreme lab cam from his mounted on his head. And this is a time lapse of taking Eucharist bread. This is over a 48-hour period, and of course you can go see this for yourself in the Broad Museum. It doesn't obviously happen this quickly in front of you. But it does get quite bloody. Interestingly, inside of the part that holds the Eucharist bread inside of the monstrance is called a luna, which is shaped like a moon, like for the luna coming from moon, and those are paganist symbols of menstruation. So it's, in a way, it does look like menstruating blood, and you're right by thinking that there are connections to that. Then here we're trying to make our own flatbread, Eucharist bread, after we learned from some of the nuns in Philadelphia. And this is we bought this from Rome, the bread maker. You can get an idea of how that works. It's kind of just like a glorified pancake maker. And voila. And then, of course, you have to have a host cutter. That's the host cutter. You can't get that at William and Sonoma. And Eucharist bread. And there's the installation that's actually in the Broad, so you can sort of see what it looks like all together. The actual monstrance is made with sort of reference to the old monstrances of medieval times. The oculus in the center is where the bread goes, what I mentioned before. And then the pedestal holds the chemostat, or the sustained culture that's growing the organism while it's in the space. There's a close-up of the bleeding bread, the miracle. Close-up of the interior, that's the vessel that actually grows the serratia on the left side, and then a close-up of the growth in the chamber. And this is kind of like looking under the hood, which not everyone gets to see. You guys get to see that because you showed up. And you can see the reactor vessel in the center. There's 2 pumps on the top. And then on the right, there's sterile media. On the left, there's the used media. And then, of course, this isn't out there yet, but there's a Miracle on Demand kit, and that's the case for the kit that hasn't. I have the case done, but I'm doing the interior right now, which will make negative spaces where all of the various parts will fit, and then that'll be coated in a rich red velvet. So stay tuned. All right, now on to the bioremediating greenness. I thought it'd be helpful just to sort of give you a little bit of an understanding of what I'm trying to do with the work. So that's why the first piece was shown. Rethinking human exceptionalism, bioremediating greenness, and bioremediation, for those that are not familiar with that, that means you're using a microorganism to remove toxics from a specific site. So microorganisms or bacteria in general are kind of like little factory workers that can act on the molecular level, the atomic scale, and be able to cause change within that environment depending on what you want to do. You can either engineer the microbe or engineer a group or ecology of microbes to do that task. This was finished all of about like 30 minutes ago, so hopefully there's not too many typos. The Industrial Revolution of the 18th and 19th century gave rise to modern cities, removing humans from an entangled connection with nature. A growing body of genetic, physiological, and psychological evidence suggests that humans have evolved biologically and culturally to be attracted to greenness. This paper explores the paradox that the further we remove ourselves from nature via urbanization and technological development, the more we try to connect with it, and the more our means of connecting led to its destruction. It seems our need for green was so strong that during the height of the Industrial Revolution, we mass-produced arsenic-laden synthetic green pigments that were used by artists in garments, in printed wallpaper, and even as a colorant for candy. The very chemical processes artificially employed to bring greenness back into people's lives helped to contribute to the anthropogenic destruction of the environment, poisoning painters and patrons of the arts alike. The growth of modern industry and factories beginning in England during the Industrial Revolution resulted in a massive urbanization giving rise to the modern city. In Europe, new opportunities attracted multitudes of migrants. As cities rapidly expanded to accommodate this new workforce, buildings were constructed. Brick and mortar, concrete, and factories replaced grasses, leafy plants, fruit-bearing trees, and vegetation and soil, or green space, isolating us from the natural ecology from that we evolved. The rapid growth in population in 19th century cities moved at such a pace that there was not enough capital to keep up with the housing. Low-income newcomers moved into overcrowded slums. Cholera and typhoid were endemic. City planners simply reacted with apparently little forethought for our human desires for green space. And that's a Monet painting, by the way. Our affinity for greenness, or as I say, chlorophilia, probably began 30 to 45 million years ago. As humans evolved from eyes that perceived ultraviolet, or the 300 to 400 nanometer range, which would be over here, with the spectrum and the ability to perceive the color green, which is the 490 to 570 nanometer wavelength. Countless studies have indicated that humans need access to green space to reduce stress and be healthy. We appear to crave green, or at the very least have associated the color green with nature, health, and wellness. Building of the new concrete and steel urban environment beginning during the industrial age resulted in landscapes of brown and gray, evolutionary equivalents of winter and death. Color associations, however, though, are not fixed symbols, but are tied to cultural and linguistic associations, as well as to the material world. Symbolic associations of chance, money, and love were likely due to the historically unstable chemical and physical properties of green dyes and paints. Throughout Western history, green has had dichotomous meanings, a symbol of life, luck, fertility, and hope on the one hand, and a symbol of poison, disorder, and the devil on the other. Current symbolic associations with green, one being connected to nature, health, and ecology, grew out of this industrial revolution. And maybe MSU. Amateur gardening and corresponding magazines developed a mass appeal. This was no more apparent than during the Victorian fern craze or Terradomania. The fern craze was made possible due to an invention developed by an amateur biologist and naturalist, Dr. Nathaniel Bradshaw Ward. For years, Ward had unsuccessfully been trying to cultivate ferns in his London home. Like most city backyards, his home was surrounded by factories producing soot and toxic fumes that killed his plants. In 1829, in a moment of despair, he made an accidental discovery when a fern spore sprouted in a wet enclosed container in which he was growing moss. Ward realized that the noxious gases from the manufactories were destructive to the health of the plants in the city. The ferns in enclosed glass cases were able to thrive due to the fact that they were isolated from this toxic anthropogenic environment induced by industry. Ward went on to cultivate more than 100 species of ferns in enclosed containers and eventually experimented with glazed glass cases that became known as Wardian cases. These cases delivered contained and tamed nature back into the Victorian home, as well as aided colonial interests by aiding the transportation of plants across the world. That's like a whole book in itself. Further evidence of the desire for green was the development of green space, botanical gardens, and parks beginning in the early 1800s. The Industrial Revolution also marked the beginning of modern chemistry, and with modern chemistry came bright prismatic synthetic pigments, Scheele's green and Schweifeld green. Not only was there a strong desire to bring living plants to the home and build public green space, but there was an equal desire to make green a fashionable color. Scheele's and later Schweinfurt green were used as colorant for candy, dyed clothing, and other fashionable accoutrements. And soap. Wouldn't you like to use our arsenic-based soap? Gaslighting replaced candles, increasing lighting in homes, and then made it possible for darker materials to be placed onto the walls. The rich colors of the newly synthesized green pigments were printed on wallpapers and then applied to the walls. This is some samples of them. And you can see why the seductive tendencies of the color. And Van Gogh liked it too. Some wallpaper behind her, I think. And then using actually Schweinfurt green as the primary pigment. One of the most popular green pigments was invented in 1775 by the Swedish chemist Carl Scheele. Like many of the new synthetic pigments, Scheele's green, as it was known, was composed of heavy metals that turned out to be highly toxic due to the fact that the primary ingredient in the pigment was arsenic. While arsenic has been proven to have some useful properties, such as medicine to treat syphilis, a beauty agent that whitens the complexion of European women, and a highly effective insecticide, its poisonous quality should not be underestimated. So insecticides, medicine in the middle, wafers for women's skin, and then of course the elemental form of arsenic, just a representation in the top corner. And in 1874, this is going to sound a little familiar to you, Dr. Robert M. Kedzie, a professor of chemistry at Michigan State University, wrote a book titled Shadows from the Walls of Death. In an effort to raise public awareness about the dangers of arsenic pigmented wallpaper, 100 copies were sent to public libraries across the state of Michigan. Each book consisted of a title page, preface, 86 wallpaper samples taken from common merchants, and a note from the Board of Health warning librarians not to let children handle the book. In the preface of the book, Kedzie outlined the effects of slow chronic arsenical poisoning. And as it were, most of the 100 dangerous books were destroyed. Only 3 remain. One copy is here at MSU, which is the one you're looking at, one at the University of Michigan, and the third is held at the National Library of Medicine. Dr. Kedzie described the effects and dangers of the arsenic pigmented papers, and over time, the wallpapers exposed to varying environmental conditions like contrast of heat and cold, moisture and dryness broke down and dislodged microscopic particles of the arsenic dust. He goes on to say, arsenic may enter the body by other avenues than by mouth, for it may be absorbed by the skin or inhaled with the breath. The danger for equal doses of the poison is vastly greater when it is inhaled than when it is swallowed, for we take food only at distant intervals while we breathe continuously. As the arsenic dust is inhaled and suspended in the mucus lining the nasal cavities, the lungs symptoms quickly appear. And he goes on to say, dyspepsia, neuralgia, pains in the bones and joints, simulating chronic rheumatism, headaches, general disability, etc., are symptoms which often attend this form of chronic arsenical poisoning. For arsenic may show its deadly power not alone by sudden and violent destruction of life in acute poisoning, but it may take on the form of many chronic diseases. Thus, the constant cough, loss of flesh, depression of spirits, and general failure of the vital powers may lead the person to fear pulmonary disorder of an alarming type is threatened. And that's actually another image of the book in our library. The enormous distribution of these fashionably green wallpapers across Europe, and an estimated 65% of wallpaper in the United States at that time, it is not surprising that many fatal accidents occurred in children's bedrooms. Arsenic poisoning in green factories was also well documented. Workers suffered considerable symptoms of arsenic poisoning. Conjunctivitis, anemia, lesions, scars, ulcers on hands, legs, face, and genitalia were prevalent. By 1820, modern chemistry had emerged, and by 1848, more than 62 new elements had been discovered. During the 19th century, new technological innovation of bright, prismatic, and less expensive synthetic pigments, coupled with new scientific understandings of color and light, gave rise to a new rebellious and conceptual artist. This new artist rejected the art establishment. Up to this point, artists were trained in the École des Beaux-Arts in Paris, and with an emphasis on drawing, students learned about the formal characteristics of line, form, light, and shading. If a student were allowed to paint, their first assignment were to copy the old masters in the Louvre. The freedom brought about by these new materials changed what was appropriate to paint and allowed the artist to leave the studio. Painters moved away from traditional subject matter of Greek myths and royalty and idealized forms and began painting everyday people and urban landscapes. Now the painter could work in the midst of his subject, which was often nature itself. Impressionists were trying to capture firsthand the reality of light and color from the real world. Paint manufacturing was simply of chemical synthesis, and now disconnected from the material world of grinding solid pigments. The invention of tin tubes in 1841 by American painter John Rand allowed for long-term storage of prepackaged paints with increased portability. The increased convenience and commercialization of these new artist supplies separated the painter from the material world. Painters, including Impressionists, used these mass-produced toxic pigments to portray the very nature that the Industrial Revolution was eroding. And ironically, while these industrialized paints allowed painters to get more in touch with nature by painting in plein air for the first time, artists simultaneously lost touch with the materiality of producing their own paints. Thus, the human drive to recreate greenness within cities led to a series of paradoxes and contradictions. The very chemical processes artificially employed to bring greenness back into people's lives helped to contribute to the anthropogenic destruction of the environment. The further we removed ourselves from nature, the more we tried to connect with it, and the more our means of connecting led to its destruction. Our research is focused on bringing to the fore these paradoxes and contradictions by recreating the processes necessary to create toxic green pigment or paints, to use them to paint impressionist-like paintings, and then to detoxify them using nature itself. We recreate in a chemically safe and controlled environment, which is what you're looking at now, Shields and Schweinfurt or Paris green from scratch, reestablishing the painter's material connection to his paints. These paints will be used to produce forged, impressionist plein air paintings. To remediate the toxic nature of the paints used in these forgeries, bacteria capable of metabolizing arsenic into safer forms will be sprayed on the paintings in sealed, self-contained bioreactors. Remediation, however, will reduce the green pigments to black, destroying the fake paintings. The reduced pigments will then be burned, returning them back to nature. Ideally, There will be exhibitions of the actively bioremediated paintings in enclosed glass aquarium reactors, as well as remediating paintings in conjunction with authentic Impressionist paintings in galleries, such as that at the Chicago Art Institute. Performances of pigment synthesis and paint production while wearing neon green hazmat suits and utilizing chemical safety cabinets, video and sonification of chemical data. All these elements of art production, along with formal lectures, will help to engage public discourse about our need to interact with nature. And this is actually in the X-ray crystallography center over in chemistry. You're looking at the X-ray crystallography machine to the right, which can analyze by sending X-ray light or radiation through the crystal, and you can identify what it is. The green that you looked at, what I was making the slide before, is then analyzed, and you can see the bottom chart, which actually shows that it is indeed Scheele's green and matches what you would find in a painting from that era. And then that's another image on the top left of kind of how that is assimilated into data. These speculations and scientific inquiries into humankind's drive to artificially reconnect with green are transposed into a series of artworks and experiments that investigate the various indexical relationships embedded in the production and use of Scheele's green. We recreate the chemical processes by which the pigment is produced and transformed into paint, reestablishing the connection to materiality and that industrialized two paints destroyed. We produce Scheele's green wallpaper and recreate the moist conditions under which the paper becomes infested with fungus that breaks down the pigment into gaseous arsenic, compounds that poison Victorian household. We experiment with various bacterial ecologies that can metabolize and remediate the arsenic and transform it into safer compounds that can then be recycled with less toxicity, thereby enlisting nature to rectify the very factors that threaten it. And in the ultimate irony, we plan to collaborate with a well-known forger to produce an Impressionist painting that is then bio-augmented by microbes that will simultaneously destroy the painting while making it safe, revealing the double anthropogenic lie at the heart of the art, which is that green is deadly and the art fake. That's it. So yeah, I left some room for questions, and then my collaborators on this too, which I realize I failed to mention, is Robert Root Bernstein, who I think a lot of you know in the room, and also Dr. Kazim Kashefi, who is an extremophile microbiologist expert, of which I'm indebted to very much for learning how to work with this anaerobic bench practices for the last 5 years in his lab.
Any questions?
Sure. Yeah.
Did you decide what painting it's going to be?
No. So to be a good forger,
Yeah.
in case you didn't know, Peter,
I'm a photographer. We can forge everything.
you want to create a painting that's not known. You want to create the lost painting, the one that sort of fits in between sort of the recorded images. So then you can say, oh, this came out of my aunt's attic, and look, here it is. So it's going to have to be some sort of a research painting in that way, but it'll probably be something well known like a Monet or a Manet or a Cézanne or Renoir, something like that. The devil's in the details still, but yeah.
So if we could go back to we don't have to look at the slides, but if we could go back to the first part of the talk about the historical accounts of actually people in Hellenistic times, people in the Middle Ages, seeing this bloody reaction. One of the things that seems to be a common thread in the historical accounts is that it actually drips and drops. Have you been able to achieve that type of? Because I mean, what I'm seeing in the video is more of it seems to be sort of more of a solid kind of nature, or at least somehow integrated into the bread. And I'm not seeing the possibility for kind of interact with people in that way.
Well, the trick is that you still have to keep it contained, because as soon as you take it out of the reactor, which is a sterile space, then it's also to succumb to all the other types of molds and bacteria that are in the environment. So that's one of the reasons why it's contained as part of the process. But if you let it grow in the right conditions, it can get very gooey. I mean, if you want to we can do some drippy stuff together at some point, but it does get to that point.
So how long will it take you anticipate it taking the microbes to do the job of remediating?
Well, from what I can tell in the literature that I've identified so far, it's going to take probably 2 organisms. Arsenic comes in 5 species or ionic forms. There's the natural occurring kind, and then there's the kind, the non-organic kind, which is the more dangerous type. So there's like basically arsenic 3 or trivalent arsenite, and then there's arsenate, which is pentavalent or 5 electrons in the shell, if you remember your chemistry. And essentially you're going to need one organism that's going to be able to transport or oxidize with the electron donor process the arsenite or the trivalent arsenite into the pentavalent form. Once that's done, then you need another organism to come in that can actually absorb the arsenic 5, because that's still toxic but not as bad, and basically absorb it onto the surface of the cells. Once then it's almost acting like a sponge that you can then remove. And then once you've removed it, then you've essentially taken care of the arsenic problem. I didn't get too deeply into that part, but yeah.
So what's your time frame of working on these projects? I have an idea of something that takes a while, like some time, that you could, with the 2 that you showed us, and walk us through the timeline.
Yeah, so the irreverent, that's probably around, if you start from when I had the idea about 2.5 years ago, and then about 2 years in production, the microbiology of that piece is pretty simple. The only thing that we had to figure out is how do you get the consistent red, and then there isn't really much literature on that. One is the temperature, and the other is pH. You have to have a higher pH, and then it bleeds quite well. But it does take a long time to sort of work out the details and figure out how it's going to all come together. And then also when you're relying on collaborations too, those kind of things can increase the time to production kind of thing. As far as the bioremediating greenness, I've been just doing sort of the basic sort of research, the desktop research now for about 6 months, trying to find. And then as I was doing that, I actually I found out that we had that book that was right here from one of our own, and which to me, in terms of the center, is quite interesting too, because it makes you realize how much is here and how much is unutilized or even promoted. I mean, the fact that we've had, I think, 3 Nobel Prize winning scientists over the years. Did anybody know that fact? I mean, those are things that we should be promoting in the school, and that's something maybe the interdisciplinary center can do too, to help with that gap.
Another process question. So as you're working through the research, I can imagine you will have many other ideas and discoveries like that. Do you keep like a list of things that you'd like to do someday and research further?
Oh yeah, definitely. Like the one comment where I said it's another book, The Colonialism. So that's something I've discovered over the past few years, is that I think we can owe most of colonialist pursuits to plants. I mean, I know normally we think that humans are the sole responsible, especially the Brits, for doing that. But it turns out that it's probably the fact that agriculture and the fact that we could then take and bring back these crops and use them in order to create industry. I think there's a lot of relationships to that. So as an example, so yeah, you'll run past a piece of information and you kind of file it for a later date, or maybe something comes to you.
That's a provocative take on colonialism, which makes me think about some of the conversations regarding new materialism and object-oriented ontology. I'm curious to hear your take on the relationship between human and non-human agency and whether the ideas of decentering the human are possibly dangerous in the sense that maybe they absolve us of responsibility to one another.
No, I don't think. I mean, I think it. In contrast, it increases our responsibility to one another, just because we've. But with the representation of the Vitruvian Man, of Leonardo da Vinci, what that essentially did is means that we're almost gods. And when you're almost gods, you don't really give a shit about anything else that's around you. You don't care about the environment. You don't care about other species. And I think it's that kind of mentality, that way of thinking, that really has led to where we are now. Now we're in a state where we're not sure if we're going to have to control global warming, or if it's even possible. You know, my house got flooded, which I don't think happened like that before, right? And the sea level's rising, and it's happening at a very alarming rate. So unless we sort of get on task and start really being a little more critical of how we operate and how we see ourselves historically as well, I think we're in a lot of trouble. Yeah.
I have a couple questions. One is kind of related to Zach's question. The first question for the first part of the talk was, you spent a lot of time talking about the historical...
I can't hear you. There's like a tractor just a second.
Yeah, there's a big loud sound outside.
Sorry.
I was saying that my first question has to do with the first part of your talk. Can you hear me now?
Yeah.
And you spent a lot of time talking about the historical context of the interpretation of this bleeding bread, and ways in which it was used to persecute groups of people, like Jews, for example. And I was curious about the historical relationship of your project to right now, what you see as its historical relevance to the moment that we're living in at this moment, and how constructing this machine that can produce the miracles on demand is related to some sort of historical moment that you see us living in today. Mm-hmm. And then my second question also has to do with human exceptionalism, because I think I kind of understand where you're coming at with this idea of rethinking human exceptionalism, because with the Anthropocene, we see that we've created this massive shift in the environment, the geological record, which is a product of human activity, but also it threatens to overwhelm us. But I'm curious about how you see the relationship between the idea of questioning human exceptionalism and then coming up with human technological means to overcome the problems that we've caused, or engage in these remediating projects, or sort of come up with technological solutions to various types of problems. I wonder if you don't see there as being the continuation of the idea of humans as almost gods who can intervene in the environment and develop knowledge about the world that we live in order to continue to engineer it according to our needs in some way.
Mm-hmm. Yeah, I guess, well, for the second question, I'll do that first. I would say that it's definitely a double-edged sword. It's all full of paradoxes, these ideas. But we're kind of in a zero-sum game at this point. Like if we don't act, we're not going to be able to survive on the planet. So I think that we have to basically rethink the way that we interact with nature in terms of just taking and pillaging, and then look at models of sustainability. And so I think when technology of course can be good or bad. And if we move in sort of a positive direction and with sustainable directions where we're conscious of the organisms and the forms we're working with, that's sort of a difference than what was done in the past. In terms of the current status of bleeding Eucharist today, so in the United States, that's probably not as much thought about. But if you go to Europe, it's much more on the minds of the public that's there. And I tend to do a lot of exhibitions in Europe, so that's kind of where that came from. But as you saw, like in 2009, there was another reported incidence of a miracle as well. So it's still being used as a currency by the Catholic Church in order to bring people on to into Catholicism, essentially. But I also think, you know, we've gone through a few decades of revisionism, right? Revisioning histories based off of marginalized populations. I'm just simply, instead of using people to revision, I'm using other species and other organisms as part of that matrix of revisionism.
So it's the idea that you're wanting to show people who might become Catholic that the miracles they have scientific bases? Is that part of the goal?
I think not necessarily, but definitely to get them to question what they're learning. I mean, I came out of as you know, a Jesuit background, and a lot of the priests that I learned from actually would consider themselves almost atheists. So I think that there's a wide spectrum in terms of Catholic belief, but we tend to see like these very sensationalized versions more than we do the sort of the background information. So not necessarily. I mean, there's a lot of great, just like anything, there's a lot of great things that the Catholic Church has done too. They've got a great Pope too, in my opinion. I like it. No, I'm not trying to persuade. I'm just trying to. I think an artist's job is to probe or question and challenge, and so I'm trying to do that challenge.
Have you, I missed a little part. Have you mentioned why you decided to pick that form to solve this question? You know, you finalize your idea with this kind of form.
So the monstrance is, that's a very traditional form in the Catholic Church, going back probably to like maybe 500 or 600 AD. But the form has very specific connotations with symbols, pagan symbols, that were then appropriated by the Catholic Church. For instance, the round circle part is the sun, and you'd actually see like a solar flare on some of the old ones, the more Baroque or fancy ones. They'd have, it would look like a flare. In the center is the oculus, which just means to look at. And so inside the oculus is where after the bread would be blessed by the priest, and once the bread is blessed, it then becomes the actual literal body and blood of Christ. It then is placed into the oculus for everyone to see. So and then the difference is that I kind of updated in terms of my own aesthetic, but then I used materials also in the sort of the indexical way that the medievalists used materials. They had a very different relationship to art than we do. Materials that you would use would be very literal, like in terms of like an indexical image, right? When there's a lot of times it's described as when you see fire, there's smoke. Smoke is an index, a direct relationship to the fire. And so the materials were thought of in that way in medieval times. So I tried to use materials, contemporary materials that did the same thing. So the white material of the monstrance is made out of Teflon, right? Nothing sticks to Teflon, right? It is like a purity about it, at least when you think about when you're working with it. And then stainless steel and glass, which are often used in the laboratory setting. And I'll have very specific working modes and uses.
Another question. You also mentioned you find a collaborator on the shared common interest. And therefore, how do you find the funding supporting the production of the discipline?
Well, some from our gracious leaders in the college, some from the National Science Foundation. I was fortunate enough to get a $250,000 grant about 2 or 3 years of being here. That funded a lot. And places like Creative Capital, other funding agencies like that.
And more of a process question. I feel like I ask this a lot, but kind of related to the idea about funding. Like when you're applying for something, it's very logistical. Like if you're applying for something, do you know all this stuff that you're going to do in advance? Because you have all these amazing moves that you make. Like, oh, I studied this, and I thought about this, and then I went to this. Do do you have a list of all this stuff like before you apply for funding for a project, or does that happen organically? And how do you convince the funders that that's okay?
Well, as I jokingly say, I've often been sort of the bastard child of the art school, right? Because you don't exactly fit into any niche specifically. But no, I mean, it's like it's more organic. You come up with the idea, then you start. A lot of times I'll start with writing, which I know a lot of artists don't do, but I start there because it helps me to sort of work out the problem. And then if you start out with the writing, then you have something that you can use to approach funders. So it's very much part of what I call an epistological methodology. In other words, like with the Bridge program that was mentioned by Michael, how does an artist engage on various epistemologies and creative practices that aren't necessarily art with a capital A, but nonetheless creative in themselves. And so it's sort of a combination with that and these other processes is how I work. And then the other thing is that it does open doors to other funding sources that you wouldn't normally be able to apply to. Like NSF would have totally been out of reach if I was just or only making paintings. But if it includes microbiology, in this case it has a lot of useful forms too. I mean, bioremediation is a very new field that has a lot of potential. And like I didn't show it in this group, but then the other bioremediating process is with the great work of the Metal Lover, where I precipitate gold out of seawater, which is an actual bioremediating process too. And so, when you work in this way, you have more choices.